In this video, we'll discover functions. Let's bake a cake first. Or for our purposes, let's assume you have to bake a cake. You assemble the ingredients, you have your recipe at hand, and you have an oven ready as well. Once the batter is ready, you put it in the oven for baking and set the temperature and perhaps a timer. Now this is where the oven takes over and does a couple of things. It heats up, starts monitoring the temperature, auto cuts off when the heat reaches or exceeds the desired temperature, and switches back on when it begins to cool down. Likewise, the timer ensures it switches off the oven after the set duration has elapsed. In a nutshell, the oven is like a program which is doing a couple of things on the input you've provided, the batter, and once done, it provides you with the output, a cake. To you, the baker, how the oven works on the inside is immaterial. You just provide it with an input and you get a processed output. And that is what functions do for us in programming. They accept data for processing and return back results, just like mini programs within our programs. The inside of the function can be made up of complex logic, but to the one who needs its services, it is quite like using our oven. Just provide input data and get your results back. Now, so far you've learnt about variables, data types, data structures, input-output, loops, and conditional statements. When we put together these pieces, we get a computer program. Now let's take an example of the program we built in the previous video to check if numbers in a list are even or not. Let's strip this program down to its core logic, where it accepts one number and tells us whether the number is even or odd. Let's assume for a moment that this ability to detect if a number is even or odd is required in the application that we are building in multiple places. One way to do that is to just repeat these instructions wherever such an ability is needed across your application's code. But this would only lead to repetition and redundancy, which simply means that the same code repeated again and again is unnecessary. What if you could write this functionality once and reuse it as many number of times as you want? This is where you would want to use functions because they allow you to encapsulate a group of instructions or statements, as we call them in programming, under a single unit. Think of them as mini programs inside your programs that are designed to do one specific thing. Once done, you can simply ask the function to process data and send back the result. This way, the actual logic required would need to be defined only once in your application and wherever needed can be called. The term calling here refers to executing the function, providing it the data that you need to process, and once that is done, the function returns back the computed result. This way, we can put together complex logic inside a unit called function and use it anywhere in our program without worrying about its inner workings. It also helps us to break down an application's logic into small units that perform a single task. Functions are known by many names across the programming world. They are known as subroutines, methods, procedures, and subprograms, but we are logically talking about the same concept. In pseudocode, a function can be expressed by using the function keyword. A function will have a name which is used to call it for use, and it accepts input data to process in the form of variables that are typically known as arguments. A function can accept multiple arguments as needed to process the outcome. This is your inlet into the function. A function then has a body, which is essentially the statements that describe the inner workings and logic. Once data is processed, the function returns back the result to the caller. We can use the return keyword to express this action. This pseudocode function, as you can see, takes two numbers in arguments x and y and returns back their sum. Now, by itself, a function will not do anything. You need to call the function in order to get it to work. So, to use our addNums function in pseudocode, we'll just say call addNums with 10, 20 returning sum. And then we can use display to show the resulting value 30 to the user. In simple words, the function is executed, passing in 10 and 20 as values to the x and y arguments. The function does its work, returns the result, which we are storing in the variable sum and displaying the output back to the user. Functions are thus incredibly useful and is something you will use all the time to write code that can be reused and maintained properly. One of the benefits of functions is that if you wish to modify the underlying logic of a function, you just have to do so in one single place where the function is defined, and the changes would be evident wherever the function is being called in your application. So rewriting our odd and even number program as a function would look something like this. Here the function accepts a number in the argument x, and if it is even, returns back number is even, or else returns number is odd. We can then easily use it to check if a number is odd or even. Simple enough, right? And here's our function in pseudocode with its JavaScript equivalent for comparison. So what would be the kind of functionality that developers would want to build as functions? Well, I'll leave you with some use cases of functions. A function that accepts a username and a password and returns back true if the user is found and the credentials are correct, or false if the credentials are incorrect. Such a function would be used to implement authentication in web and mobile applications. Next up, a function to compute distance between 2 points on the map. This would take two sets of coordinates as latitude and longitude points and compute the distance. Such a function can be used in delivery logistics and navigation applications where the distance has to be shown to the user based on their current GPS location and the location of the destination. Next up, a function that sorts data based on a given criteria. Sorting data is a critical requirement in computing. We actually sort data more often than we realize. For instance, sorting products by the highest rating first, sorting travel destinations by the shortest distance, sorting your contacts alphabetically, sorting your bank transactions by date, and so on. As you can imagine, functions allow us to create reusable units of code easily. Within pseudocode, we can use the keyword function to define a function and return to let the function return back the result. Then the keyword call can be used to express the task of calling the function. Now that you understand functions, let's also talk about object-oriented programming as a concept in the next and final video of this module.